Oops, I did it again. I didn't put it in studio mode. Okay, what is up YouTube and Twitch? We are live with Advent of Code Day 7. As you can see here, we're slowly building up a picture that will slowly be revealed as we get through the days. But yeah, we're on the 7th today. As I've said every day, Advent of Code is a sort of Christmas coding challenge. We're going to be writing our answers in Python, and I'm going to try and make it accessible if you've never coded before, but we're on day 7, so you can go back and watch the last few days where I explain some more basic stuff, like what a variable is, what a function is, and stuff like that. So yeah, let's dive in. We're using something called REPL.it, which means you don't need to know how to set up a Python environment. You can just use that. So I've sent that in the Twitch chat at the moment. And Advent of Code at adventofcode.com. So let's check out task number 7. Day 7, handy haversacks. You land at the regional airport in time for your next flight. In fact, it looks like you'll even have time to grab some food. All flights are currently delayed due to issues in luggage processing. Due to recent aviation regulations, many rules, your puzzle input, are being enforced about bags and their contents. Bags must be color-coded and must contain specific quantities of other color-coded bags. Oh dear. Apparently, nobody responsible for these regulations considers how long they would take to enforce. Oh dear. This doesn't look good. I'm just getting my puzzle input just so I can see what that's about. What on earth? This looks awful. Okay. Right, for example, consider the following rules. Light red bags contain 1 bright white bag, 2 muted yellow bags. Dark orange bags contain 3 bright white bags, 4 muted yellow bags. I'm not going to read all of those, but we get the idea. These rules specify, just turn that down again. These rules specify the required contents for 9 bag types. In this example, every faded blue bag is empty. Every vibrant plum bag contains 11 bags. And so on. You have a shiny gold bag. If you wanted to carry it in at least one other bag, how many different bag colors would be valid for the outermost bag? In other words, how many colors can eventually contain at least one shiny gold bag? Okay. In the above rules, the following options would be available: a bright white bag, which can hold that shiny gold bag, a muted yellow bag, which can also hold a shiny gold bag, a light red bag, which can hold the bright white bag or the muted yellow bags, which can in turn hold shiny gold bags. So in this example, and then light red as well. So in this example, the number of bag colors that can eventually contain at least one shiny gold bag is 4. How many bag colors can contain at least one shiny gold bag? Jeez. And then we've got a couple of 100 different types of bags here. So this is sounding like a sort of like a tree problem, right? So we've got so in this example, is there a, let's have a look at the, oh boy, not too excited about this one, and also not confident we'll get it done, but let's see. So we've got, we know this bright white bag, bright white can hold a shiny gold. Shiny gold, we know that muted yellow can hold a shiny gold. Shiny gold, we know that, in fact, it's not going to be a tree, is it? It's going to be like a connected graph because we can have multiple branches. So light red can hold a bright white or a muted yellow. So that's light red. Dark orange can also hold the same. So we've got something like this. Dark orange holds those. I hope there's no cycles. Although we don't know that there aren't any. No, we'll see. Okay. Shiny gold can contain olive and vibrant plum. So we've got olive, vibrant plum, And then we've got dark olive has blue, dotted black, blue, dotted black, dotted black. Vibrant plum contains faded blue and dotted black, which is this one. Faded blue has no bags, dotted black has no bags. So, is this a tree? No, I don't think so. So we've got, I can't read my own writing already, this is going to be a nightmare. Which ones contain the colours? But shiny gold isn't even the end. In fact, we've got 2 shiny golds here, so we don't need that one. Okay. How are we going to even do this? We don't know what the starting node is. We need to create like a map. I guess we could use like a dictionary and then have that dictionary. So we have like a dictionary that says, you know, light red, and then we put the keys that are valid after that. So we have a list of bright white and muted yellow after that, and then those can be accessed. And then we can sort of crawl down the list recursively. So that kind of makes sense to me. It doesn't sound fun though. Okay, so I'm going to take this as a test input for now. Inputs.txt. I'm not feeling good about this one, I'll say that much. Okay, main.py. So let's just start with this test input. Input equals, let's call it test actually. I don't like using the word input. Okay. So does everything says contain? Yeah, so we can kind of split on bags contain. And then that will split comma separated bags as well. Feel like we're going to need these numbers at some point as well, so we can't really afford to lose the numbers. So we can do, let's call it like key value equals test.split, and we're going to split that on bags contain. So then we can print out key, we can print out value, and we get light red and 1 bright white bag. So next I'm going to split it on, can't really split it on, I guess we have cases with more bags than 2 as well. So we need something that's going to let us split this string. Oops. So we've got that. We can split on commas. 1 bright. So we've got light red, and I want to get the words dotted grey, striped fuchsia. So how can I safely do that? Maybe let's do that so we get rid of that space there. So now we got, if we comma separate, we'll get, okay. So now we can do value.split, and then do split that on commas. So now we've got 1 bright white bag, 2 muted yellow bags. So I'm kind of concerned about the word bag being slightly out of our control. We have to be aware of this no other bags option. In fact, some cases we can't use. Like for this contain no other bags, this is going to fall down. So we do need to think about that. And there's a full stop at the end. How am I going to deal with this? can't split on the word bag either. Like red bags contain. So bags contain is safe, but then we need to be looking for. We could split on either bag or bags, comma. So I'm thinking like regex now, which I don't want to think about really. Okay, let's split on regex Python. So take a regex re.split. Split on certain phrases, Python, maybe list of phrases. Can it take many things? On multiple strings, Python. Yeah. Yeah. I don't. Regex is one of these things that I always forget. So regular expressions, you can basically pass in certain patterns, but what does that do? White space characters, I guess. Split on multiple characters, Python. Okay. So we can do this split on the strings. What does that mean? Okay, so this line is an OR that lets us put multiple characters in. So we should be able to say right, let's undo. Let's keep that one. Let's undo all the way to this one, and let's see what we're working with. So I want to split on bag or, in fact, I want to split on bag, comma, or bags, comma, or bag, full stop, or bags, full stop. Oh, do they need to be strings? What's it complaining about here? Looks okay, let's see. Expected string or bytes like object. Ah, here. Test. Oh, no value even. So now if I printed this one, good pattern is putting these imports up at the top. Okay, didn't work. Bags. I've got bags here. Oh, okay, so it's trying to match the space, which doesn't make sense. That's kind of annoying too. I guess it's empty though, so we can deal with that. Bright white, bag, bags. So there's an extra space that I'm trying to get rid of here. Yellow bags. Too muted yellow, looks good. There's a full stop there because it's matching bags first. So now the order is going to be important too. No, wait, why is it matching bag? shouldn't be matching bags without the full stop. Well, it's a little hard to see because of the multi-line here. Oh, well, that makes sense. No, it doesn't. Should I just not worry about spaces? Maybe that might make things easier. Doesn't look easier. Okay. Well, that's slightly better anyway. We've got like an extra full stop, which I don't like, but let's start importing our strings here. So import file line by line Python. And I want to do this. So now we've got our lines, we don't need this test thing anymore, and we can say for line in lines, colon. Now we're starting to get, oh, no we're not, it must be line, and this is all good, and file name is not correct, inputs.txt. Okay. So if we look at this for a moment, so giving it the input, 1 bright white bag, 2 muted yellow, and we're getting 1 bright white, 2 muted yellow, 3 bright white, and it's adding spaces after, so that's not quite right. 1 bright white bags. So let's put the space before as well. To get rid of that trailing, and then space before these. Okay, shiny gold. Cool, and we kind of get no other as a key, which is actually quite useful. So in all these cases, it looks like we can reject the last. Yeah, we can. So bags equals regex split, and then I'm just going to get everything except the last. And let's print bags. So this should just ignore that extra full stop we have at the end. So you see we have, why does it say dark orange there? Why does it say dark orange? Oh, that's the key. Okay, cool. So we've got a key dark orange, and now we've got a list with numbers and bags. So for now, oh, it still works for the no other case. That's cool too. So for now, let's say we don't care about these numbers, so let's get rid of those numbers. So for bag in bags, move numbers. For bag in bags, we don't actually need to do that, do we? We can do bags equals. No, we do need to do it for bag in bags. We need to do bag dot split empty, so that will return like 2, shiny, gold. Then we need to slice only the. We need to slice the first one onwards, which will just give us shiny gold, and then we can join them back up again, I think. I don't know if join exists, but we'll see. So now if I print bags, we should have a new let's join. Yeah, let's join Python. String join. String join takes a string. Oh, that's not what I want. Join list into string. Maybe you just cast it to a string and that works. Is that what I want? Okay, I need to pass it, so I need a string. I need to do something like this, so string spaces dot join, and then wrap it around that. So now we've got nothing. Did I do that wrong? Looks the same because I'm not overwriting the bag for bag in bags. I need to like bag equals this. Looks the same as well. Oh, I can't just get rid of the first one because of the no other, but I guess I can just assume that's not the case. Is this slice wrong? Bag.split. What am I doing? So for bag in bags, let's print bag. And bag. So we have the bags. Bag dark olive. Let's print bag.split. Oops. Bag.split. So that gives us 4 dotted black. If I do bag.split 1 colon, that should give me just dotted black, which it does. And if I do quote dot join bag split 1. Whoop. Now we should be looking at something that says just dotted black for that first case, if it ever runs. Yeah, faded blue, so that's all good. So now we have okay, so now we have like something that could go in our list, right? So we could start building up this dictionary. So bagdict equals dictionary. And then here we could be saying okay, so for each key we need to say bagdict key, oops, no we don't, we say bagdict key equals, and that will be a list. And then in here we're going to append to that list this new value we've got. So we're going to do bagdict key dot append, and we're going to do this. And now we should build up a bag dictionary. So let's get rid of some of these prints. Bagdict. That's not going to print anything, is it? Bagdict. Okay, so now we've got this weird looking object, but we can see, so we've got, oh, that's not right either, the key is a bit wrong. What do I split on? Does that split bags contain? I need to put a space at the front as well. Yeah, I'm not printing anything. -dictionary. So I'm just going to swipe this function. Pretty print is just like a way of asking to format something nicely. I'm going to try pretty printing this bag dictionary. Might make it a bit easier to read. Cool. So what we've got here, I threw away the picture I drew. But let's just check it. So light red bag contains a bright white bag. So light red, bright white, muted yellow, looks good to me. Then basically want to like iterate over these bags and see which ones could contain shiny gold at some point. So for each key in here, we can go light red and we can just search through these keys. And if we find a shiny gold, we can stop. How are we going to do that? So go crawl down all the values. But there are cycles. Are there cycles? I think there were cycles. I need to write this graph again. I'm going to try and do it with a smaller font this time so I can actually read it. So I got light red, which goes to bright white, muted yellow, bright white, muted yellow, and then dark orange does exactly the same thing. So we have dark orange, which goes to here, which goes to here. Then we have bright white, which goes to shiny gold. Then we have muted yellow, which goes to shiny gold and faded blue. Faded blue. Shiny gold goes to dark olive. And vibrant plum. Dark olive goes to faded blue. And dotted black. Faded blue goes to nothing, dotted black goes to nothing. Okay, so we could be crawling basically down this list looking for our gold, which is here. And what we want to do is say, so when we enter here, we need to split and go into each key. And if we find into each key, call the same function again. And find the shiny gold. Okay. Well, we've got an object at least that's looking kind of tree-like. So we might be able to do it. There's no cycles here from what I can see, which is good. But I'm not sure we can guarantee there's no cycles in the actual full input. I guess we can test. No, we can't really. I'm not going to be able to visualize it. I'm going to trust that there's no cycles for now. And just see where that gets me. So next we need to go find shiny gold. And that's going to take a bag, which is going to be bag is going to be key. Bag is key in that bagdict object. So an example, let's start with dotted black just to deal with this other case, and we're going to return false for now. So we're going to call find shiny gold on dotted black. Dotted black. Okay, so let's stop doing this pretty print for now. And get false, and I'm going to say print bagdict bag and print bag. Maybe I'll do entering close quotes bag, entering dotted black. The keys are other for bag, in bag. No, this is bad. Okay, for inner bag, in outer bag, print inner bag. Outer bag doesn't exist. We need to use this. Okay, so now it prints other. So next we need to do so if it's other, we know we're at the end of our list and we can stop. So let's just start with that for now. So if inner bag equals other, oh, this is not a good one. Inner bag equals other for comparison. Otherwise, we're going to return true. So all we're doing now is checking if this is a root node, basically, if this doesn't lead anywhere else. So it should only be true for faded black and dotted black. Faded black. Oh, faded blue, that's why. Faded blue should be false. Anything else should be... What else have we got? I guess we can start at shiny gold. We know that's in there. Shiny gold. True, cool. And we can, I guess another case we can now assume is if inner bag equals shiny gold, then we know we found shiny gold, so we can confidently return true after that. True. Cool, so this is what we can call our sort of base case. So this bit here is kind of our base case. Not really, because we've not really started looking at recursion. I'm just trying to make sure we've got all this logic. So what we're doing now is checking a current bag and saying if this bag has other, we know we're at a root, so we can stop searching. If it has shiny gold, we know we're at shiny gold, so we can stop searching. But we've not dealt with everything else, and what we're going to have to do is, if it's anything else, we're going to have to go deeper, right? We're going to have to go cool, find shiny bag, find shiny gold even, on our new inner bag. So this is not going to be a good one. So now it'll print at least everything. So when it enters shiny gold, it sees dark olive and vibrant plum. It enters dark olive, sees faded blue, dotted black, and other. So they terminate. Then we come back to this outer loop and we see vibrant plum. And it enters vibrant plum, finds faded blue, sees other again, sees dotted black, other, then it returns true because it finds shiny gold here. Why does it even get to the else? Oh, because because this isn't. So we need to, I don't know if we need to check that. Hang on, why is it returning true? Because I wrote return true out here. So now it returns nothing. Because the inner bag isn't shiny gold. Well, this is where I need to write something that's actually good instead of just iterating through stuff. I'm just thinking, is there some sort of shortcut here? So we've got our tree. We've found shiny gold already at the top there. Do we need to check? Okay, So let's build this up again. File new. So we've got that. We need what's called a base case. So what's the simplest thing we have is basically that we check one, so we have one node, and this is either shiny gold or it's not shiny gold. So we need to deal with that. So we need something that returns true if this is shiny gold and false if it isn't, which we kind of have already. So if in a bag other, so we've got that. But that doesn't check this one, does it? So for example, if we call it on shiny gold, it should be saying true because this one is shiny gold. So I think our base case needs to be checking this bag, not the bags within this bag. So it should only be returning this for other instead of the empty bags, which isn't great, but that's okay. So this should be bagdict bag, and this needs to be outside of the inner bag iterations. So kind of like this. This is what we call a base case in recursion. We've got our base case. That's actually okay. And this will be our recursive case. So it should now, so when it enters shiny gold, it should be hitting this one. Bagdict bag. Bagdict equals shiny gold. Why doesn't it equal that? Print bagdict bag. Huh? Oh, I didn't need that. I need bagdict. Just bag. That's why. Just bag is the bag I want. Shiny gold. That's why this isn't working. There we go. True for shiny gold. It will now take other as its false condition. But that bag doesn't exist. So do I need to check if bagdict bag is equal to other? That's not right either, is it? Because it would be the first element. So if this bag is bag, or this bag only contains the string other, then it should fail. It's not quite right. Let's print. Let's not worry about the return false for now. Let's not worry about returning anything for now. Let's just see what we're working with. Huh? I commented out. Come on. Right. Oh, maybe it wasn't wrong. Obviously other isn't a key we can access there, but dotted blue was? Dotted black was? Okay, so if bag equals, so we can't do that, but that's where, this is where I made the mistake, I think. So if we can check if its bag is bagdict dotted black, return this list other. So we need to check if it's an empty list just with other, not an empty list. There we go. Okay, so there's our base case. So we can call it on an individual node and it will return true or false. Now what we want to do is have another recursive case. So when we check, for example, dotted whatever, dotted orange, dark orange, it's going to check faded blue and dotted black. And it's going to return if it finds shiny gold in either of those. So this is where we need to say for in a bag, in bag dictionary. We then need to call find shiny gold. on that inner bag. And this will return false if it finds it. And let's just print that out. False if it doesn't find it, true if it does, which it shouldn't do. Okay, so dotted black doesn't have anything, so I need that dotted orange, dark olive. There we go. So let's look at dark olive. Okay, so we're entering dark olive, we find faded blue and dotted black. We enter faded blue and we find nothing, so false. We enter other, find nothing, false. So now we can enter something above shiny gold and see if that works. So let's try muted yellow. So what we get here is a true, but now what we need to do is sort of bubble that up. So this is where we need a clever return. So for each, so this here needs to be returning true or false, and if we get a true at any point, we keep that true. So we can do true times false. No, we can't. True plus false. Yes, we can do true plus false. I feel like I'm a robot now. Whatever we return, we can basically sum, and if it's any number over 0, we know at some point in that crawl we find a shiny gold. So this will always be true or false, but we need to return that up a level. So when it's called, okay, so let's do something like is found equals find shiny gold. So that will be a 0 or a 1. We then need to use that somewhere. So we need to say, how are we going to collect these? Is found. So what we want to do is, as we crawl through this, we should say, so if we start muted yellow, we'll have an is found as 0. We'll get here, we'll have an is found as 1. Then we can stop searching. So can I not just do like if? Return true. Does that work? Feels this is a nightmare. Print muted, print light red, we get true. Found shiny. I hate recursion, this is awful. Found shiny is true. So now if I stop printing this stuff for now, and I iterate over the keys, okay, I'm gonna go for key in bagdict.keys. So this will return a list that I can iterate over of those keys. I want to do print find shiny gold, and then instead of that it needs to be the key. Okay, none's not good. I'm going to put the key at the start as well. So we should find it if we're in this one, this one, this one, or this one. We can't look in itself, can we? So this shiny gold shouldn't be correct, because like shiny gold isn't within shiny gold, but that does give us a few values. So that's kind of a mistake that it returns true there. Can I get rid of that? Is that going to break everything? Yeah, that's why it works. Okay. I could just take away 1 and assume that there's only 1 thing, so this is getting like really sloppy, but whatever. I'm not confident on this one. We also have some nuns, which are when it doesn't terminate but it doesn't have a shiny gold. So maybe we just need to say something like is found equals false, and then we always just return, basically making sure that we always return something. So return is found, and then this could just be is found equals true. So this is like a common, you shouldn't have like multiple returns inside a function, so this is a good way to get around that. I don't need to do this if it's false, do I? This can just be an if now. But other doesn't. No, it does need to deal with other. Because otherwise it'll try and crawl in. Yeah, we do need to deal with that. Shiny, this shouldn't be as true. Is it? It does need to be something, but let's see. Yeah, no, that's got to be true. Can I set is found to equal to true? Okay. So this one is a problem. We shouldn't be returning true when we find, like we shouldn't be looking inside shiny gold and seeing shiny gold. So that's not good. But I'm going to leave it for now and take away one. Total equals 0. Total equals total plus shiny, find shiny. And then I'm going to do total equals total minus 1. And then I'm going to print total. Hopefully, hey, what gives there? Is it adding? Total equals 0. Total, let's print total each time in this loop. What the heck? If it's true, it should be adding 0 plus true. What? Find shiny gold key. This shouldn't be in my for loop. Thanks. Okay. Right, I've got 4 now, which is what the answer should be. I have the lowest confidence I've had out of all of these because I've cut so many corners here. Like recursion is extra tricky, tree stuff is extra tricky, but let's see what we get. 355. Should we try pretty printing that bag dictionary? See what it does. See how complicated it is. It's not too bad. Did I just see shiny gold? No. There's a lot of shinies in there. So there's loads of stuff in there though, not more than enough. And much more than I think I can do much with. So let's not worry about that one. But nice to see that it doesn't look too complicated. Oh, what was my answer? 355? I hope this is right. Oh my gosh, I cannot believe I just did that without Googling any of it. Oh my gosh, we did it. We earned another star coin. We're unstoppable. What is that? 13 star coins? When did we hit? I can't believe it. We're almost there. Okay, right. Now I'm only giving myself about an hour to do each of these, which means I think I have about 9 more minutes to see what part 2 is about, and I'm assuming I'm going to have to count the number of bags. Part 2, it's getting expensive to fly these days, not because of ticket prices, but because of the ridiculous number of bags you need to buy. Consider your shiny gold bag and the rules from the above. A faded bag contains 0 other bags, blah, 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 blah. I didn't have time to read. A single shiny gold bag must contain 1 dark olive bag and its bag within it plus... Oh. Okay. Let's see if this even works. Oh, so we don't need to check for shiny gold bags anymore though, right? We just need to count how many bags are inside our shiny gold bag, so that's useful. Okay. But we didn't keep the numbers, so we don't know how many of each of those bags are inside each bag. So what can we do here? We can add, instead of lists, we can store each. This is going to break everything. I need to change everything. So this whole split needs to, let's do build def. Build bag dict 1. Lines. And I'm going to indent all that. Is that going to make me, is that still going to work? No, because I didn't call it. Right, then I need to do bag dict equals build bag dict lines. This isn't gonna work, is it? This bag dict isn't a list now, so I'm gonna need to do this bag dict. Oh no. What's that complaining about? I need to return my bag dict. Return bag dict. This needs to be in here. And then I need to say bag dict equals, yes, okay. Then I need to do def build bag dict 2. This one's going to try and basically persist the numbers, so we need to make some changes here. Build bag dict 2, and I'm going to do build bag dict. Build bag dict 2, and I'm going to move all this. I could have done myself some favors here, because now I can't call any of this. Okay. So now it doesn't do anything, which is what I want. We have our bag dict, print bag dict. So what I'm going to do is try and keep those numbers. So at what point did I lose the numbers? Print value. Okay. And then I split it. This was the bit where I removed numbers, so hopefully if I get that. Huh? Bag split. Well, I'm very confused. Okay. Bag in bags. Print value. Okay, so I've got these individual bags. I next need 2 dark red. If I get rid of this, do I keep the numbers? Yes. So instead of adding to a list, I need to add to a dictionary. So this is going to be a dictionary where the bag is going to be the key. So I'll say bag dict key equals, no I won't, bag dict key bag. It's going to equal the number. which is going to be the first value in this string of bag.split on open spaces. I'm going to get 0, that's the first value. So this should build me up a big weird dictionary. Can you tell my confidence is almost gone? Okay, so we got almost there. So 2 dark red. So I do actually need that logic still. No, I don't. I need bag split. Right, let's do this. Bag split. Num of bag equals bag split 0. Bag name equals bag split. Oh dear. Okay. So I still need it without the number, so it's good that we did that in the first place. This one, bag name. You know what? I can actually just do this, bag split. It's not great, but I can add these together. Plus a space, plus the second bag's name. Then I can use bag name and num of bag. Shoot. Is that because of the other? I'm trying to be too clever. Let's go. This one. This one. Hey, okay. Good time to use this pretty print function again. Oh dear. What's that 2 about? So we've got dark red, so shiny gold contains. Hang on, I thought I got rid of that. Bag name should be bag name join split. So that needs to be bag split, just the first one up. No? Because I'm not even using bag name. Hey, that's looking good. What the heck am I going to do about this? And I didn't use a number of bags even. Why are they all 2? Should they all be 2? Yeah. What did I do? How did I do that? Oh, okay. Okay. Right, we've just hit an hour, so I might stop now, but I'll try and finish this up. And I'll post the code in the chat and stuff like that. So thanks for watching, everybody. Let's cut to that thanks for watching screen, and I'll see you tomorrow.